Okay, there's 4 congruence patterns for triangles that you need to be aware of. Okay, the first is SSS. The S's simply stand for the lengths of the side. So if you have 3 sides that are equal to each other, then your triangles are congruent. You don't necessarily need all 6 pieces of corresponding information in order to determine triangles are congruent. You can actually get away with just patterns of 3. So one of the patterns is SSS. Another pattern is SAS. Here the A represents angle. So when you look at these 2 patterns, involve 2 congruent sides. These are the only 2 patterns that have 2 congruent sides that you can choose from. In addition to this, you also have a couple patterns with 2 congruent angles. So you have AAS and ASA. These involve 2 congruent angles. And I'll talk more specifically about what these mean or how they're situated. And then I'm also going to talk to you about the 2 common patterns that do not work. And those patterns are AAA and SSA. These ones do not work, but they're commonly missed patterns. Okay, so let's take a look at each of these here really quickly on an individual case. Right, when you're looking at the SSS congruence pattern, if we were to identify, let's say we begin with a triangle, and if I ask you to figure out how many different triangles can you create given these same 3 sides of this original triangle. So the way to demonstrate that, let's say we label this triangle ABC, and let's duplicate all 3 sides on this segment. And so if we duplicate AC, we can simply find the length of AC. Okay, so this tells us that our point C is going to be down here. We can duplicate the distances AB and BC as well. Okay, so here's distance AB. So we know that point B is going to lie somewhere on this curve or this arc. And we can do the same thing here. The distance BC. We know that point B has to lie somewhere along this arc. So we found our point B. Point B is going to have to lie right here. And if we connect this, there's no other places that these intersections could take place other than the exact same triangle right below it. But when you look at this, you are able to observe that given any 3 sides of a triangle, there's one and only one triangle that you can create with those 3 sides. And so that's the SSS congruence pattern. In addition to SSS, there's also an SAS congruence pattern. If you were just to take a couple segments here, and you arrange your elements or label your congruent elements in this manner, is there enough information to decide whether these triangles are congruent or not using one of those 4 patterns? Okay, you have 2 sides. The fact that the angles included in the middle of these S's is important to the pattern. Okay. For SS or SAS congruence to work, the angle has to include the sides in its angle. Okay. So when you extend the angle that's given or involved in the problem, that angle has to contain the sides that are congruent as well in order for SAS to work. So here's the angle with the 1 tick mark. It passes through, or is formed by the side with 2 tick marks and the side with 1. Same thing here. The angle with 1 tick mark passes through the sides with 2 and 1. Therefore, this one is enough to fulfill that pattern of SAS. What about this one? Would this fulfill the pattern of SAS? You have two sides and an angle, or two, oops, let me come back. I jumped ahead of myself on that one. Okay. So here's a case where you have two sides and an angle, but are they in the same pattern that you're looking for? No. Here's a case where this one does in fact include the angle that you're looking for. However, in this case, your angle does not pass through or include the 2 tick marks, so this one is not necessarily congruent. Now, it's possible that it might be, but it's not necessarily true. Okay. What about this example? Is this an example of congruence of triangles by SAS? If we look at the first triangle, let's call it WXZ. W, X, and Z. Is this triangle congruent to the other triangle that's kind of mirrored across? Yeah, because they have this shared side, XZ, and that passes this pattern of two sides, the angle between that side. And so I could identify triangle WXZ congruent to, here W is opposite the side with 2 tick marks, so we choose Y. X is opposite the side with 1 tick mark, so we choose X. And then finally Z is the angle with 2 tick marks, so once again we'll choose Z. Okay, so you can establish your congruence just looking at those 3 pieces of information for that problem as well. All right. The next are the 2 patterns involving angles. I'm going to just kind of pair together here. AAS and ASA congruence. Okay, so once again, if you just took your pieces of information, okay, would these 2 triangles be congruent by either AAS or ASA? You have 2 angles. The side is not included between them. Again, here's the case where the side is included. Here's the case where the side is opposite one of the angles. So what you have here is you have 2 angles. The side is opposite one of them, so we're testing AAS. And is the pattern the same for both of them? Is the side with 1 tick mark opposite the angle with 1 tick mark in both cases? Yeah, the fact that it is means you have congruence of triangles in that form. Okay, and the pattern would be AAS. Okay, and again, when you're looking here, you have 2 angles. Now, is the side included between them? Yeah, the side is contained within both angles. So once again, you have congruence of triangles, this time by ASA. All right, we are